All right, today we're solving by substitution. Solving by substitution includes solving for one variable. This is the step. You got to solve for one variable. Then what you do is you substitute that into the other equation and then solving. Then you substitute the value from step 2 into either equation and solve for the other variable. This is when you have two variables. When you have like a system where you have two variables, what you do is you solve for one, figure out what it is, and then solve for the other. Okay, that's your steps. So write these two down. So, yesterday we were solving systems by graphing. Today we're not going to graph them. Instead, we're just going to solve them algebraically. The first step you got to do is get the one variable by itself, which in this case, y has already done that for you. It is already by itself. So what we do is we take that and replace it with y, because we know what y equals. It equals 2x plus 1. So plug 2x plus 1 in for y. To solve for x, what we're doing is we've eliminated y, we can solve for x, and then we can figure out what y is. And we can figure out where these two cross. So 3x plus 2x are like terms, so that becomes 5x. Subtract 1. 5x equals negative 10, so I divide by 5. My x is negative 2. But I'm not done. I need two answers. I need an x coordinate and I need a y coordinate, because that's where these two equations cross. So what I do is I plug in negative 2 into either this equation or this one and solve for y. Which one would you rather solve? The first one or the second one? The first one, because it's easy. You plug in negative 2. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So your y coordinate is negative 3. So your ordered pair, the solution where they cross is negative 2, negative 3. That's your answer. So the problem before, step 1 was already done. We'd already solved for a variable. Has it been solved for a variable here? No, so we got to solve for one. Which one do you want to solve for? Okay, but are you going to solve for x or are you going to solve for y? I would solve for x because it's by itself. It's a lot easier to single out. So I'm going to subtract 2y to both sides. I find that x equals 6 minus 2y, which now I substitute that for x in the other equation. So 3 times 6 minus 2y minus 4y equals 28. First step, distribute 3. 18 minus 6y minus 4y is equal to 28. I combine like terms, I get negative 10y. I'm also going to subtract 18 to both sides. So I get negative 10y equals 10. I divide both sides by negative 10. Y equals negative 1. What I do is I take that and plug it into either this equation or this one. Which one you want to do? Top one, okay? So I can actually plug it in the right here because I've already solved for x. What is 6 minus 2 times negative 1? So what would 2 times negative 1 be? What is 6 minus negative 2? 8. So my ordered pair is 8, negative 1. That's my answer because x equaled 8, y equaled negative 1. Any questions? Yes. Write this down. Alright, so we've already solved for y, so all I got to do is plug that in here. Negative 6x plus 3 times 2x minus 4 equals negative 12. Distribute the 3, I get negative 6x plus 6x minus 12 is equal to negative 12. I add my like terms, which cancel each other out. I get this. Negative 12 equals negative 12. Which means there's infinitely many solutions because it's an identity. Negative 12 equals negative 12. I got rid of x. So this would be a case where they're the same line. Right? They don't cross one time, they cross at every point. They're infinitely many. Okay? Any questions? Alright, so we need to solve for variable, but it's already been done, so I'm going to just plug 2x minus 3 in for y. So 2x minus, now listen, don't miss this step. Okay? This is minus y, which y is 2x minus 3. If you plug it in like this, you'll get it wrong. Because y is negative, what you got to do is make 2x negative and 3 positive. You got to distribute the negative out. Treat it like it's negative 1 times y. Negative 1 times 2 is negative 2. Negative 1 times negative 3 is positive 3. Okay, so don't miss that step. So 2x minus 2x plus 3 is equal to 8. 2x minus 2x cancel each other out. 3 equals 8. Is that a true statement?
No.
Does 3 equal 8? No. So it's no solution. Well, because they don't cross. These two lines are parallel. If you were to put these on a graph, you would see they're parallel, meaning they never cross, meaning they don't have a solution. All right? So if you get something like this as a false statement, your answer is no solution. Here's your homework.